Distance vector routing protocols will pass periodic copies of the entire routing table to all neighboring routers around them, usually in a broadcast format, but sometimes also in a multicast format. A distance vector routing protocol will calculate cost and metric based purely upon a hop count factor in almost every case. In some cases, though, it does so based on the vector distance, which defines both the distance and the direction. Now, a distance vector routing protocol does not always use hop count, but is simply a way of understanding its functionality. In fact, a path from one side of A to the other side of D indicates that we must go across multiple routers. Multiple hops is actually the distance, and it must travel in this direction to get there. Distance vector routing protocols periodically pass routing table copies to their neighbors. Therefore, if a route goes down in between, or if a route results in a change to the network, the route will still be automatically propagated to any router that is still online. This means that networks can be known as unavailable or available through a backup route if redundancy has been built into the network. But the biggest problem with distance vector routing protocols is, in fact, their primary attribute. A distance vector routing protocol passes a periodic copy of the routing table updates to all neighbors via broadcast. Some of these protocols pass the updates as often as a 30-second interval, and a calculation of distance is not always the best calculation, especially from the standpoint of some of the lower-end distance vector routing protocols.